Hi friend, today we are discussing about pa- topic power electronics. First of all, in power electronics, we will be dealing with the title Thyristor. Thyristor consists of four alternate P and N layers forming three PN junctions. Thyristor is also called as SCR and it consists of four alternate P and N layers, that is PN, PN, forming three junctions. There will be three junctions. The anode terminal is outside the P layer and cathode is outside the N layer. Anode is found outside the P layer and cathode is found outside the N layer. A contact welded to inner P layer forms the gate. Here inner P layer is this P that forms the gate. So we can depict the symbol of anode configuration as this is the configuration of thyristor. That is first P junction is P is anode and this one is cathode. N is the cathode and gate is the middle P, that is gate. Okay, the symbol, this is the configuration. And next we can see the symbol of the thyristor. We know SCR is a PN junction diode. Here we know the representation for PN junction. Here it is denoted as like this. This is the anode portion, this is the cathode portion, and here comes the gate. This is the symbol for SCR. SCR means silicon controlled rectifier. Next we can discuss the VI characteristics of an SCR. It is shown as below. X-axis and Y-axis. This represents the anode voltage and this represents y-axis represents the current in ampere. Here it is the reverse breakdown voltage. This point is called reverse leakage current. Here this point is called forward leakage current. This current is represented IL and the line extrapolated represent IH. This is IG equal to IG1. This voltage is BBO, breakdown voltage. Here Ig is equal to 0. The behavior of a thyristor can be explained by two transistor model. The two transistor model is depicted as PNP. This is one transistor. NPN. This is another transistor. P is the gate in SCR. N is the cathode. And P is the anode. This is the two transistor model of SCR. Thyristor can be turned on by applying a positive gate signal. Other triggering methods are dV by dt triggering, high triggering and low triggering. So, to turn on a thyristor, gate signal must be positive, or other methods include dV by dt triggering, high triggering, low triggering. When a thyristor is triggered, gate loses control. It can be turned off by decreasing current to less than holding current. Holding current is given in the dV by Vi characteristic, that is IH. When this line is extrapolated, we get the IH, that is the holding current. Holding current reduced means, or decreasing the current to holding current, we can turn off the thyristor. These are the methods for turning on thyristor, that is gate pulse positive, dV by dt triggering, high triggering, low triggering. To turn off a thyristor, we have to decrease the current to holding less than holding current. The turn on time of thyristor is less than 3 microseconds and turn off time is between 10 to 300 microseconds. Turn on time is less than 3 microseconds and turn off time is between 10 to 300 microseconds. Thyristors are available up to about 10 kilovolt and 1200 ampere rating. The rating of thyristor is 10 kilovolt and 1200 ampere. For high voltage and high current circuit, series and parallel connections of thyristors are used. So we can say thyristor is used for high and low voltage circuit. When connected in series, that is for high and low voltage circuit, it can be either connected in series or in parallel. For high voltage, when connected in series, the voltage across the thyristors are not equal. In series connection, voltage not equal. When connected in parallel, the current through them are not equal. In parallel, current are not equal. Therefore, thyristor in series need static and dynamic equalizing circuit. Derated operation improves reliability. A snubber circuit is used to limit dV by dt across the thyristor. Snubber circuit is used across thyristor to limit dV by dt. It is necessary to turn on and turn off a thyristor at proper instant. Turning on is done by applying a positive gate signal. Turning off methods are called commutation method. Turning off method of thyristor is called commutation method. Commutation can be natural or forced. There are natural commutation and forced commutation. When an SCR connected to an AC source, current goes through its natural current 0 at the end of every half cycle and a reverse voltage automatically appears across it. It is called natural commutation. That is how natural commutation occurs. When SCR is connected to AC, current goes through natural. When current AC wave, we know the form of AC wave. When current is drawn through SCR connected to an AC, when SCR is connected to an AC source, current goes through its natural current 0 at the end of every half cycle. Here the current would be 0 and reverses the voltage automatically. This is called natural commutation. In DC circuit, there is no natural current and forced commutation is necessary. In case of DC circuit, no natural current. So forced commutation methods include resonant commutation. Resonant commutation or class A commutation. Second one, self commutation. That is class B commutation. Auxiliary commutation. That is class C commutation. Fourth one, complementary commutation. That is class D commutation. External pulse commutation. That is class E commutation. Natural commutation is also called class F commutation. Natural commutation, that is called class F commutation. Class F is only applicable to the AC circuit.